Hi again, everyone. Welcome back. Today we are going to talk about something that, well, is familiar to all of you, but maybe we weren't quite sure how it worked. That's static electricity. I know we hear about electricity, maybe it sounds a little scary, and uh, hearing about building up the electric charge on ourselves sounds like something from a science fiction movie. But the truth of the matter is, it happens all the time. Every time you go down a slide at the park, and this poor kitty cat ran into some packing peanuts. And if you've ever had that situation where maybe you're trying to throw a packing peanut or something like that away and it just kind of sticks to your hand because it won't let go, well, it's all about static electricity. Now, static electricity technically is going to be the buildup of charge on an object. And the word static kind of has to do with, in this particular definition, has to do with staying in one place. All right? And we can build up static electrical charge a few different ways. Maybe you've rubbed your feet on a carpet before and had that the friction of your feet and your socks rubbing against the carpet build up a static charge. You can get a static charge built up on yourself just by contacting something that has a built up a charge, and we're going to see in the next video a little bit about how that can happen, similar to what's happening in the diagram and picture given to you, and then also by something called induction. And we talked yesterday about an electric field and how that can affect things. Well, that happens because of induction. So induction happens because the electric fields give off this invisible force field that's going to affect other electrical charges. If you remember yesterday, we talked about an electric field is going to, reach through space, and anything that has an electrical charge is either going to attract or repel it, depending on whether it is an opposite charge or a like charge. And in induction, we can actually induce a charge on another object. Now, we got a little simulation that I want you to try. It's through the PhET program at the University of Colorado. And there's a link here, so when you go to your notes on this slide, you can click on this link and it'll take you there. And you'll be able to use balloons and this person's sweater and the wall, and you're going to be able to see how those charges affect one another. So be sure you play with that a little bit, have some fun, add balloons and take them away, and see how the charges can change from one thing to another as they interact. Also, there's going to be a second video on static electricity that we'll have you watch that I made after this one is done. Now, sometimes we're all familiar with the event when the actual zap happens, when there's a discharge of static electricity. You rub your feet on the carpet and you touch another friend's finger or nose, and pow, you get that little shock. Well, that's what we call a static discharge. And that's where those charges are going to even out, essentially. They've been built up in one spot and they want to balance each other out. One enormous discharge of static electricity is what we know as lightning. And this is prime time now, coming into the spring and the summer, when we're going to start being able to see examples of this. Now, back in the early days, of course, they had no idea what lightning was or how it worked, and so they thought of a god up in the sky throwing lightning bolts by the name of Zeus. Well, we have a little better handle on the concept now, but we do want you to actually do a little reading on our online text. There's a link on our Schoology page that you can go to, and if you go to the section on static electricity, static charge and discharge, read through that. There's also a couple of simulation and a short little video about seeing lightning in slow motion that I want you to view. And then there are going to be some questions to answer. So in summary, we learned about static electricity. It's the buildup of charge. We know that it can happen due to friction, contact, or induction. And static discharge is going to occur when the electrons are going to jump from where they've built up to another place. Lightning, of course, is the large-scale example. So I want you to do that PhET simulation. Play with that a little bit. There's, again, a link on the notes of this particular page. There's a static electricity video number 2 that I want you to go see, where we get to play with something called a Van de Graaff generator, and you'll get to see my daughter's hair stick up a little bit. And then we got a little quick quiz to wrap it all up.